Welcome back, students. We have started the topics or the problems of the topics that are conditions are equilibrium. So during this last class, we have done this one. That is, we were asked to calculate the resultant of magnitude of the forces in the plants in which it lies. Then we are heading towards the next one. That is, a meter rod is putted on a knife edge. This one meter rod is putted on a knife edge placed at a 40 centimeter graduation. This is a 40 centimeter. It is found that the meter rule balances horizontally when a mass which has a weight of 0.45 Newton is suspended at 15 centimeter graduation, as shown in the diagram. Calculate the moment about the knife edge in this balance and the force due to the mass of the ruler. The weight of the roller is 0.90 Newton. Calculate the position of its center of gravity. So these are three questions basically asked. What you are given, first of all, see the main values given. What are the given? Given are, if you look at here, it is BC 15 centimeter. From where to where BC is this one. Here it is BC. And AB is 15 centimeter this one. BC is basically this one is 40 and this one is 15. Subtract these two, you will be getting the distance of BC from point 40. So it's basically 25 centimeter, and the weight of this one is basically 0.45 Newton. Meter rod is 0.90. Now the torque due to mass of the rod, you have three questions for that. A. Torque due to the mass of the rod produced. Number B. Position of center of gravity. And how will you do it? How will you think to calculate the torque? This is basically in balance condition, tau 1 should be equal to tau 2. You will apply second condition of equilibrium. So when you will apply second condition of equilibrium, torque produced in this direction must be equal to torque produced in the other direction. So this one. So it means what is the distance 0.25 and 0.45. So it will be, and 2 is equal to BC multiplied by this B and C multiplied by W1. Here is a W1. So you have calculated tau 2. So you have calculated tau 2 and the value of tau 2 is this one. If you look at when you apply the second condition of equilibrium, why? Because this one is equal to tau 2. So you have calculated tau 2, torque produced at 2, the W1. So applying the second condition of equilibrium, this shows that the total amount of torque in one should be equal to the total torque to the other. So it is CD multiplied by the weight, this one. That must be equal to BC multiplied by W. BC multiplied by W. It should be equal. So from here you have calculated moment arm, that is CD, at what the centimeter, the distance it is acting, and you have calculated 0.25 meter. Now from end A, the position of the center of the gravity, from which end? This one A, it will be equal to AD. This one is A, this one is D. That is equal to BC plus CD, and BC plus CD, that is equal to 40 centimeter. AC plus CD, here is the AC, here is the CD. Distance of these two forces from the point of rotation. So it is 12.5 centimeter. So here is the point at 52.5. This will be the CG of the point.